All right, going over some of the questions you guys had on 5.5. All right, so we are looking first at question 12. Let me check exactly what the directions were for this. It says use the rational root theorem to list all possible roots, then find any actual rational roots. All right, so so as we look at this, so the first thing I want to do is come up with my list of P's and Q's. P's are all the factors of -2. So that could be positive or -1, or positive -2. Q are all the factors of my leading coefficient, and my leading coefficient here is 2. So all the factors of Q are also positive -1 and positive -2. So all my different combinations of P over Q would be, let's see, I can go 1 over 1. I can go 1 over 2. And again, the positive, negative of those. I can go 2 over 1. Or I can go 2 over 2, but 2 over 2 is the same thing as 1, so I've already got that listed. All right. So all of my rational roots are right there. There could be up to 3 of them. All right. But they're somewhere in these 6. All right. So what I want to do is graph this and at least give me an idea of where these rational roots might be. So I've already got that, cheat a little bit, I've already got that typed in my calculator, 2x cubed plus 5x squared minus 2x minus 2. All right. And again, I just always make it a habit of hitting zoom 6. You could just hit graph, but I just, I like to take a look at that. And as I look, again, my possibilities here are where this thing crosses the x-axis. Again, knowing that it's got to be in this list, right? Positive or -1, positive -1/2, positive -2. All right. So as I look, this thing looks to be out past like -3. All right. So again, while this is a real root, it must be irrational. All right. Something that involves a square root. So we're not worried about that one. I've got that one there, and I've got that one there. That one looks to be maybe 1, maybe a little bit less than 1, but regardless, doesn't look like I'm looking at 2 or -2. All right, so maybe positive 1. Let me try that, because again, that's in my list. So I go second trace, and I want to find the value when x equals 1. And it's not 0, right? It's 3. Okay, so 1 is not one of my roots. All right. If I look at another possibility here, let me look at that one there. Okay. Looks less than or bigger than -1. Let me try -1/2. All right. So if I do second trace, and then I want to find the value when x is -1/2. I get 0. Okay, so one of my roots of this equation is -1/2. All right, so one of my roots is -1/2. Now, I got to find the others if they're out there. Okay, so I'm going to do synthetic division here. So I go 2, 5, -2, -2, and I'm going to divide that thing by -1/2. So now I do my synthetic division, add and multiply, right? Add and multiply, add and multiply, add and multiply, and I add. Okay, so here's what I get. I get a quadratic that looks like this: 2x squared plus 4x minus 4, and I want to know when that equals 0. Now, like the one we talked about in class today, these are all divisible by 4, so I get x squared plus 2x minus 2 equals 0. Now, again, like we talked about in class, you can go to the quadratic formula, but especially if this is 1, this wouldn't be hard to factor, except when I start looking for factors of -2 that add up to +2, there aren't any. Okay, so that tells me this thing is not factorable, and if it's not factorable, that means the other 2 roots must be irrational. And again, if you want to take the time, A is 1, B is 2, and C is -2, to try to find those other roots. Well, remember, we can always do the discriminant. Okay, b squared minus 4ac, because that's what's underneath the square root. Let me just show you that. We've got nothing but time on a Friday. So if I look at b squared minus 4ac, the thing that's underneath the square root in the quadratic formula, b squared would be 4 minus 4 times 1 times negative 2. So this would be 4 minus negative 8, which is going to be 12. Which means when I do this, I'm going to be doing the square root of 12, which doesn't come out pretty. It's an irrational number. All right. So since all they're asking for here are the rational roots, the only rational root is right here at negative 1/2. Okay. So while this thing does have 3 real roots, the other 2 roots must be irrational. They must, well, we can see they involve the square root of negative 12 if we would have gone ahead and tried to do the quadratic formula there. Okay. But again, it's coming up with your P's and Q's, your P over Q list, and then looking at the graph and which one of these 6 does it look like is a possibility until you find it. And then from there, getting to a quadratic and then trying to solve it either by the quadratic formula or by factoring, but recognizing that this is the only rational root. All right. I hope that helps. Again, this was number 12 on section 5.5. Let me know if you guys have any other questions. Take care.